All right, so this is a presentation I kind of threw together at the last minute. Been kind of busy the past month or two, so I kind of forgot about this month's webinar, but put it off until a couple weeks ago. But I threw this together, and I'm actually quite like this presentation. I think it's pretty good. It's on technical skills for Agile development. So, all right, why is this not advancing? There we go. So it's kind of hard to talk about Agile without first talking about the old way of doing things, which was the waterfall method, which some of you guys might actually be using right now. Whoever just joined, I'm getting some static, so I'm going to mute you, but feel free to unmute yourself if you have a question. Well, actually, yeah. Actually, I don't know if you'll be able to unmute yourself. To let you. All right, I'm going to mute you. So, oops, they disappeared. Okay. So in the old waterfall model, right, we gather all our requirements, and then we move to the design phase, and we design the entire system, and then we build everything, and then we test, and then we deploy, right? And these are all separate steps, and they're all very segregated from each other, right? You're in one stage or the other, and the big problem with this is that it doesn't deal well with change, right? So if we're in the building phase and we're writing software and we realize that, hey, you know, our design says we're supposed to do things a certain way. And as we're building it, we realize, well, the driver for this piece of hardware or whatever won't let us do it exactly the way that we designed it. Well, then we got to go back upstream to the design phase and redo our design. And then when we change that, then we got to go make sure that all our requirements are still met. Right? And you end up swimming upstream, and water is supposed to flow downstream, not upstream. So it's a big pain in the butt process to go back and redo all that and start all over again. And really the problem stems from the fact that in the waterfall method, we have this big plan, but the time frame is really long, right? It's on the order of months or years, right? So, you know, waterfall projects isn't like a couple days or a week. It's, you know, several months or a quarter, a couple quarters out, or a year or something like that. And really what you're fighting is, I thought I changed this. This should say certainty, not uncertainty. Sorry about that. That should say certainty. And why does that keep coming on? All right, so, right, you're fighting this idea of planning and certainty. So think about your own personal life. If you want to plan what you're doing tomorrow, you can plan that with very fine granularity. You can say, I'm going to wake up at 8 a.m. and I'm going to go to the gym, and then I'm 9 a.m. I'm going to go to work, and you know, you can even plan where you're going to eat lunch and all that. And if you're doing it one day out, it's pretty easy to predict what's going to happen one day out. There's very little that could happen between now and then to interrupt your plans, right? It's always possible. You're never 100% certain, but you can be fairly certain. If you're planning for something next week, a week out, right? Immediately in our brain, we stop planning that level of granularity, right? We get a little bit broader, like, well, these are the 4 or 5 things I want to accomplish next Monday or next week or whatever, right? Because we know that there's a lot more uncertainty. There are more things that could happen between now and then that would throw us off. If we plan a month out, it drops even more, right? Planning for a quarter out is really hard, right? We can have an idea of what we want to do, but comparing that to reality, right? We never really know what's going to happen. Then if we go a year out, right, it's really hard to plan on anything because, you know, we can't be certain about what will happen, right? But if we go back to the waterfall thing, when we set these requirements, this is exactly what we're doing. But then because the time frame is so long, by the time we get to deploy it 6 months or a year later, those requirements have probably changed, right? So when we're doing the requirements, we're predicting what we're going to need 6 months out. And that's really hard to do accurately due to this kind of curve. And so Agile has this big long time frame, or sorry, waterfall has this big long time frame. When we do Agile, what we do is we shrink all that down and we do all those steps, but we do them in the time frame of a week or 2 week long sprint. right? And because in a week or 2 weeks, we can't get a whole lot done, right? We break our project up into what we call sprints or iterations, right? So we take all the things that we want to add, we create a list of them, and then each iteration we work on a tiny chunk of them, right? But we do the entire cycle for that chunk. And this gives us a whole lot of benefits that we're going to talk about. So one of the big things, though, when we do this agile transformation is on an organizational level, it kind of wreaks havoc. And part of it is Agile has these two principles, and you can go read the Agile Manifesto, but it has this principle of self-organization that like the team should be able to organize and make their own decisions. And it has this idea of people over process, right? And that's very intentional because what it's about is when we're doing our iteration, right, we're gathering information because we are interacting with the customer, we're building software, we're getting feedback. And so we have this information that tells us that, hey, you know, we need to make a change. We need to change what we're doing. But we as developers in a traditional organization don't really have much decision-making authority. So the information has to travel up the chain of command through several layers of management to get to somebody who can actually make a decision. And by the time they make a decision, it filters back down, we're already on to the next iteration, right? So we don't really have time for this. And on top of that, right, as the information filters up and down, it's like a game of telephone, right? By the time the information actually gets to the decision maker, they don't have all the information. So they're making a decision based on incomplete information, which makes them more likely to make an incorrect decision or a decision that doesn't quite make sense. And then when it filters back down, you know, their decision, the managers, you know, sometimes misunderstand it and don't implement exactly the way the decision maker even wanted it to be. So it's just a mess. And Agile is all about pushing the decisions down to where the information is. It's about giving the developers, right, more autonomy and authority to make decisions. Now, if you come from a traditional organizational background, or you work in a big company, it's very much top-down control, right? And so they don't like giving up all that control. And there's a whole lot of discussion about how to make this work in your organization, and there's all kinds of frameworks and SAFe and Scrum and all these things on how to make this work. And that's a lot of what, when people talk about Agile, that's a lot of what they talk about, right? Because it's a dramatic change to the way we manage software projects. Now, that's an important thing to do, and that's important to have those discussions, but really as frontline software developers, engineers, we don't have a lot of say over this, right? We can tell our management how we would like to work, and we can, you know, ask them to allow us to do this and give us more decision-making power, but ultimately that's a management decision, right? We don't have a lot of control over that. And our choice pretty much becomes either try to educate them and get them on board or move on to somewhere else.
Oh my gosh.
But where we do have a huge amount of control is on the technical side. And because we're changing the way we work, because we're changing the way we work, we need a different set of skills, technical skills, in order to make all this work. Okay, so before we move on to the technical skills, here are just two books that I happen to like. These are some of my favorite software development books. The Agile Samurai on the left is more of a practitioner's type book. It's got some really good advice on how to get started doing Agile, particularly if you're not doing Agile at all at the moment. And it kind of walks you through the whole process. And it does really good on the process side of it and the management side of it. It does talk about some technical skills, but it just kind of mentions them. And that's kind of where I got the idea for this presentation. And we're going to go more in depth on some of those technical skills. The other book that I like about Agile is The Nature of Software Development. And it's by Ron Jeffries. He's one of the signers of the Agile Manifesto. And it's a much higher level book. It talks more about the process side and a lot about the why we do things a certain way and what the principles are behind it. And it's more for like a high level architect or CTO or somebody who's managing a larger team. And they're both very good. I'm going to throw a whole bunch of books out there as we go along, just to give you some further stuff to read about. So the technical skills that we're going to talk about, the first four are the ones that are mentioned in the Agile Samurai book. So there's unit testing, test-driven development, refactoring, and continuous integration. And then I added one at the bottom because source code control and Git, I think, are really important in order to enabling all these other things to happen. So, right, the first goal of Agile, right, is to deliver working software and deliver it often. Right, so we want to deliver working software at the end of every iteration. Right, and part of the reason for that is we want to show the business that we're producing value constantly, and we also want to get feedback. Right, so by handing them something that works and runs and that they can use, then they can use it and say, we like this feature, we don't like this feature, can we change this, can we change that? And that gives us some feedback to make sure that we're on the right track. Right, in the Agile process, you don't really get any feedback. And so the thing is, when we want to ship working software, how do we know that it actually works? And the way we know it actually works is that we test it. So if you're doing the waterfall method, right, you can do waterfall with unit testing, but typically unit testing is not really a big part of doing waterfall stuff because you have this site acceptance test or factory acceptance test that you run at the very end before you ship things out, right? And that presents a couple problems. Oh, this is not advancing. So first of all, it's a very high level test, right? You're testing the entire system. So you're injecting a signal at one point, and the other side, you're looking at some report, right? So if the report's not right, well, where did the bug occur? Did it collect the right data? Did the data not get processed correctly? Is there some problem with the reporting? You don't really know exactly where the problem is. So that's one problem. The other problem is because it tests everything, it requires the entire software package to run. So if you got 3/4 of the software done, but you're missing one chunk, you can't really run the site acceptance test or factory acceptance test, right? So it forces you to wait until the very end to run the tests, which leads to the first problem, or compounds the first problem, because A, it's very high level, it's hard to pinpoint bugs. B, like, you don't run them until the very end. So by the time you find the bugs, right, you've got all this code to sort through to figure out, well, where's the problem at. Also, in our world, at least in the LabVIEW world, it requires hardware, right? Because usually our systems are testing something in the real world. So we've got a bunch of PXI chassis or CBOs or whatever. And the site acceptance test, factory acceptance test, like test from the hardware level up. And so therefore, if you don't have the hardware available, you can't really run the test. And often when we're writing stuff, we might not have the hardware available, right? Because you might be developing a test system for something that's still being produced, right? They've designed some widget and they're starting to produce it, and you're just in charge of the test system that tests it when it comes off the production line, but you don't have anything off the production line yet. And the last and probably most important problem is that it's time consuming, right? Again, if we're trying to do a 1 or 2 week sprint or iteration, we don't have time to do a site acceptance or factory acceptance, because like when I worked at Westinghouse, the site acceptance test and factory acceptance test took like a week or 2 weeks to run. We can't do that because that'd eat up our whole iteration, right? So we need something more focused, doesn't require all the hardware and software, and that runs really quickly. Right? And we need to run that at the end of every iteration so we can make sure that the software actually works, so then we can show it to our customers. And that's where unit tests come in. So they run really quickly because they're only testing a tiny part of the code, and they're testing it in isolation from all the other code. And they work really well as regression tests. So as we add a new feature, we can easily run all the tests, and then we know that we didn't break anything else. So that's a really nice feature. Because they're so targeted, it makes it really easy to pinpoint bugs. So if we find a bug, it's generally quick and easy to fix. And they have a whole host of other benefits that come along with them. So, but that's kind of how they fit into the whole Agile picture and why they're necessary. So if you want some more reading, these are the 2 books. X-Unit Test Patterns, I think, is a really large book, but I find it a little bit easier to understand. I thought the examples were a little clearer than The Art of Unit Testing. They're both good. XUnit test patterns is really good if you do if you have a large project, because it's really about managing unit tests. Because if you start using them as you write code, you'll find you write a lot of unit tests, and eventually you have, more unit tests than you have actual code. And managing all those unit tests becomes a problem. So the XUnit test patterns is really focused on how do you write tests that are reliable and maintainable over time, versus the other book is just more about how to write really good unit tests. So kind of nuanced, but they're both good. All right, so the next topic is BDUF is dead. So BDUF is big design up front, right? So in the waterfall model, we design everything up front before we start writing software, right? And that causes some problems. In some ways, I feel like this is kind of arrogant, because we assume that we know all the requirements, right? So we don't really know all the requirements, because the customer's not really that good at telling us, even if we're really good about asking all the right questions. I'm sure you guys might have heard a customer says, well, I don't know exactly what I want, but I'll know when I see it, right? And Agile really helps with this, because we're doing these short iterations, and at the end of every iteration, we're building something, and then we're giving it to them, so we get that feedback, right? And so that feedback is what then allows us to update our requirements. But in the waterfall model, it's a big pain to go back and redo all the requirements, right? And then the other thing about big design up front is it's very prescriptive and rigid, right? So we decide at the beginning, we're going to have this many modules and this many classes, and these are the methods, and this is the data type that's going to get passed around. And maybe partway through, we realize, okay, well, this module, we didn't think it had to know about this, but maybe it does. And now we want to pass this data. Well, that changes our design. And then we got to make sure our design still meets our requirements, and kind of go back up the waterfall again. And often when we design stuff up front, we include a lot of features that aren't necessarily used, right? A lot of times requirement gathering is something that we do, not something that we do in coordination with our customers. And so we think we know what our customers want. That goes back to the arrogant part a little bit. And so we come up with all these features, but some of the features aren't really that useful, and customers aren't really going to use them. And so that just causes a lot of bloat in the program, and we're writing extra code that we don't really need to. And it can cause extra bugs, and it's really bad when you have a big bug in your code and it's a part that nobody really uses. It's kind of like, why? And the other thing is, it doesn't really help us prioritize features, right? We get this big, huge design document, and we send it off to the building team, but we don't really communicate very well. Well, these are the 4 or 5 features that the customer really wants, right? We just kind of throw everything in that requirements document, and so end up designing into all those features, and then end up building them. And it kind of goes to this 80-20 rule, right? There's like 20% of the features that produce 80% of the value, right? So there's 4 or 5 key features that if it doesn't have it, it's completely useless to the customer. And usually those are the hardest ones to implement. So sometimes people will knock all the easy stuff off first, and they add all these features that aren't really what the customer wants. And then they get to the end and they're like, well, we're out of time. And in reality, you haven't really solved the customer's problem. So the way we solve this design problem of not designing stuff up front is we do what's called test-driven development. And so it starts out, you write a test. So you've got some feature or story that you're working on. The user should be able to do X, Y, Z. Then you decide, okay, how am I going to test that? And you write a couple tests. And then you write code to make the test pass, right? And you keep doing this. And eventually you end up with this soup of code. And you have this refactoring step where you look at the soup of code that you have and you say, okay, how can I take that and make some sub-VIs? How can I take that and implement some kind of design pattern? And how can I extract classes and stuff? And it kind of, the design almost evolves and emerges from this soup of code that you've created. And the little diagram on the right is the stages, right? So red is, you write a unit test to test the feature, right? And you run the unit test and it should fail because the feature doesn't exist yet. And then you write some code to make it pass. And trying to make it pass. You don't really care about code quality or any of that stuff for this brief period, just until you make it pass. And then once it passes, then you look at everything and then you refactor and you try to make it nice and clean it up. And then you go around and do it again for the next feature or the next part of your feature, next thing you want to test. And it allows you to learn, right? Because you look at what you've wrote and you're like, oh, well, I'm doing this thing over and over and over again. Maybe I should make a sub-VI out of that, versus in the beginning presuming, well, I'm going to do this all the time, so I need to make the sub-VI. So it's more, it's informed by the situation rather than you trying to impose something on it. And it really helps avoid building unnecessary features, right? Because you're only writing enough code to make the one test that you wrote pass. You're not saying, oh, well, in the future, we might want to do X, Y, Z. Right? The general principle in Agile is, save that stuff for when you need it, because if you add it now, it only adds complexity and you might not actually need it. So, and if you do need it, you can evolve your design to add that, because part of the whole principle of Agile is being able to adapt to changes, right? And adding a new feature is a change. So here's a book on test-driven development. It's by Kent Beck. It's kind of the classic on it. Test-driven development by example. It's a good book, worth reading. Okay, so if Agile is about changing direction of our code, how do we actually do that? Well, it starts with recognizing the fact that you need to make a change, right? And so we have this convenient point. So if we're doing iterations, we have this convenient stopping point in between each iteration, right? And so at the end of one iteration, before we start the next, we do a demo. We show the code to the customer. We let them look at it. We let them play with it, and then we get some feedback. And then we also do a retrospective. So we sit down, we talk with everybody on the team. We figure out what's working, what's not working. If somebody learns something, we take that into account. And then when we start the next iteration, the first thing we do is we plan for that iteration. So we sit down with the customer and figure out, we look at our list of user stories that we want to implement. We make sure those are still the stories that they want to implement and that our understanding of it is correct, right? And so that gives us an opportunity to inject some change and say, okay, we were going in this direction, now we want to go a different direction. And the actual changing of the direction is done by refactoring, right? So refactoring is about realizing we want to make a change. The code as it is doesn't really support that very easily. So the first thing we're going to do is change the code without adding any new features. We're just going to massage it and make it look slightly different, so then it's easier to add our feature. And Kent Beck said it best when he said, for each desired change, make the change easy. That's the refactoring part, is making the change easy. And he says, warning, this is the hard part, because sometimes refactoring is harder than adding the change after you refactor. And then make the easy change. And so on the right, I have the refactoring cycle. Apparently Agile people like things that go in circles. So you start out, you make a small change to your code, you test it again to make, you got unit tests, so you test it to make sure that that change didn't break anything, and then you commit it. And then you make another small change and you test and you commit. And the thing being, if that small change doesn't work, you've got source code control, you can just roll it back and try again. It's very quick and easy. So some further reading on that is a book by Martin Fowler called Refactoring, Improving the Design of Existing Code. This is the second edition. I haven't read the second edition, I've read the first edition. But one of the big things in there is it has a list of code smells. And so code smells are things like, if you look at your code and you notice this thing, you should notice it, and it should be like, oh, maybe there's a problem there. And then it gives you some tools to investigate and determine if it is a problem, and then it gives you some tools on how to fix that problem, some refactoring tools. So it's really good. I recommend it. All right, so now we got to talk about actually releasing code, right? So we know that at the end of each iteration, we want to be able to demo our code so we can show it to our customers, right? And we can tell that the code works because we can test it. but we still have this idea of how do we actually release the code and how do we get it out to our customers. And so our goal is to be able to release every iteration, right? And the reason is because we want to get feedback from our customers. So it starts with the idea of smaller features more often. So in waterfall, we might break our project down into like big, huge main features, right? Because we're going to build the software over a couple of months, and it's all one big, long process of building the software, and so we can have these big, huge features. In an agile process, we want to break everything down into chunks that fit into 1 to 2 weeks. So that means we've got way smaller features. So that big, huge feature, we're chopping it up into small pieces. And the term that people like to use is slicing, right? So we're trying to break it into pieces that start at the bottom, typically like the hardware level or the user input, and go all the way up through the program, through each of the layers to hit the database or the report or whatever, right? So it's a vertical slice. And so how we're going to do this is we're going to use something called continuous integration, right? It's going to be how we pull all these pieces together. Now, in the LabVIEW world, we often, when we talk about continuous integration, we mean automation. And it's not exactly automation, right? Continuous integration is about more than that. It's about taking all these small features and how do we actually incorporate them all together, right? So the integration part is we've got our development branch that is the code that we've released, right? And then we've got 3 or 4 developers all working on features. And at the end of our 2-week sprint, we need to take all those features and put them back into the develop branch and put them together. And then we've got to create a release, right? So that's the continuous integration part of it. Now, in order to do that well, we need to have some robust procedures for how we merge stuff together and how we bring all those together and how we test it to make sure it actually works. And that's where the automation part comes in. So we can have things where, like, every time we merge into develop, we run our unit tests. And every time we create a release, we automatically do our build, right? Run some tests and do our build. And that also helps us because it makes those processes take a lot less time, which helps us to fit everything into that 1 to 2 week window, right? Because if we're doing it manually, and maybe, I don't know what you guys do or where you work, but if you work at a big company, your release process might take more than a week or 2, right? It might involve a whole bunch of testing and a whole bunch of hoops to jump through before you can release your code. So the automation is to help us squeeze that down and fit it into that 1 to 2 week cycle. And I will make this point here. Long-lived feature branches are technical debt, right? So if you've got your develop branch and you create a feature branch, right, ideally you want to get it done in 1 sprint, but if it lasts several sprints, the problem is as soon as you create that branch, at some point you're going to have to merge it back in, right? And the sooner you merge it back in, the less chance that somebody has changed something on that main branch or develop branch. And so the less likely you are to have merge conflicts. So it kind of goes along with that uncertainty curve, right? The bigger the gap between when you create the branch and when you merge it back in, the more likely there are to be problems. So my recommendation is if you have a feature branch and it lasts more than 1 sprint or something, to either merge what you have back in and get it to a state where everything still builds and doesn't break and merge it back in, or rebase your feature branch every couple of days just to avoid that. And there's a book on this, continuous delivery. I will be honest, this is the one book in all the books I'm going to recommend that I haven't actually read yet. It's sitting on my desk, but I have not picked it up yet. So I've got a whole stack of other books to read. But this one was recommended to me by Nancy, so it should be pretty good. And I've seen other people recommend it too. So. All right, so those are the 4 technical skills that are mentioned in the Agile Samurai, but there's another even more basic skill that I think people need to master, and I feel like a lot of people use Git, but don't really understand what's going on behind the scenes. They understand just enough to be dangerous, right? They can do the basic add and commit and all that, but when it comes to merging and rebasing, they don't really understand the difference, and they don't understand how to resolve merge conflicts very well. And You know, if you ask them to like undo a merge or to like, you know, do something else, once you get outside of the handful of commands that they have memorized, they're like, oh, I don't know what to do, right? So I think, you know, as software engineers and as professionals, we use Git every day. And so I feel like it's something that's worth taking some time to understand how the tool works. And it's really not that hard. It doesn't require a huge amount of effort. But one of the reasons I really like using Git is because I feel like it gives me freedom, right? It gives me the freedom to be able to make changes to my code and know that if I do something wrong, I can always get back to where I was, right? So to me, I equate using Git with freedom to make all these changes and to try things out and to experiment. Okay? And then the other thing you get from Git that's really, really important, particularly when we're talking about agile software development and we're talking about continuous integration, all this stuff, Git really helps you coordinate multiple moving parts, right? So you've got a team of 3 or 4 developers, and they're each working on different features in parallel. Git gives us the ability to kind of corral all those things together and pull them together at the end of a sprint or iteration, right? So I think it's really important. I feel like really understanding the Git branching and merging and how that works and stuff can really help you to do that better. So that's my plug for using Git. Of course, you can do some of this stuff with Subversion, but I think it's a lot harder in Subversion because branching and merging is kind of a pain in Subversion, much more so than Git. And also, Git gives you a lot of freedom because you can do a lot of stuff locally and then, you know, push your final changes up and you have more control over when other people see what you've done, which also really helps a lot. So, all right, so some further reading on that. There's a book on the left called Git for Teams, and then the one on the right, Version Control with Git. So they both talk about Git, but they come at it from completely different points of view. So Version Control with Git, the one on the right, starts at the very bottom. It talks about how Git actually stores data in its database, and then from there builds up all the commands, right? It explains in detail how each command works. Probably too much detail in some cases, right? And then it builds on top of the commands, and then it builds up to like some basic workflows. Git for Teams starts at the exact opposite end, and it says, okay, you've got a team that needs to work together. Here are the things that you have to do as a team in order to be able to work together, and here are the Git commands to do it. And I feel like you kind of have to read both to really gain the full understanding, because, you know, the one on the right, you read it and you understand how the commands work, but it's hard to see the big picture. And the one on the left, you see the big picture really clearly, and it throws out some commands. But if you don't understand what the commands do, you can get yourself in trouble. And it just, to me, it lacks some nuance. And so I think creating both of them together really helps a lot. All right, so I want to just show you guys a quick promo video that I put together. I have this LabVIEW Mastermind group that I've been running now for about 6 months. How do I copy that? And so a friend of mine put together a promo for me. I'm just going to show it. It's only 2 minutes. Hold on, let me figure out how to share the sound from my computer, because I got to do that too. So you guys, once I let's see, share computer sound. Okay, so you guys should be able to hear this video now. We all realize that writing code just to make it work, right? That's one step. But then making stuff that's reliable and maintainable, and, you know, that other people can look at and figure out, right? That's a whole other step of craftsmanship.
And how to make good code that can stand on its own merits, right? And be able to show somebody how it works. And I think LabVIEW is a really important environment to do that in.
A lot of the time it's up to yourself to try and fix the problem. That's not too good.
One reason I want to get involved in this group is try to get more people on my team to jump on that bandwagon of not being just a code line.
advanced question about testing, and that's something I need to get back into.
And you get 1 minute to explain some problem that you're having. And then everybody else gets 2 minutes to ask questions. And then you get 3 minutes where everybody just gives you suggestions. You'll get some really, really good ideas that come out of that.
Originally from Silicon Valley.
That is, I'm kind of an intermediate. I'm looking to get more advanced, and these are some of the concepts that I'm struggling with.
I'm using JKI tester with Active Framework.
Guys, we're all seem fairly high-level LabVIEW people, but I'd like this group to be welcoming to like anybody of any level. Even beginners, I think, still have something to offer because they look at things differently. I'm hoping to get everybody together in the sense that we can all be committed to helping each other learn and grow and become better LabVIEW programmers, right? As a solopreneur, I have nobody to bounce ideas off of, and that's the thing I miss most about starting out on my own. We all kind of know our little niche very well, but maybe we're not super well-rounded, and so maybe we can round each other out, right? And pick up tips and tricks from each other and kind of fill in those gaps. All right. Let's see. So, I outlined all these skills. And it's a lot to learn. So how can we at SAS help? Well, we do have a few workshops that we put on. We have a DQMH workshop that we put on that's basically just software engineering in general. It covers a lot of stuff specific to DQMH, but it covers a lot of other stuff as well. So it's more like software engineering using DQMH as the example. We also have a 2-day unit testing workshop, which covers a whole bunch of stuff, really in depth, gets into mock objects and test doubles and all this stuff. Then we have a unit testing intro that's just for like people who are just getting started with unit testing. We don't go into the mock objects or test doubles or anything, but we do go over a technique called the humble object, which helps you to separate hard to test code. And you can actually get pretty far with just that by itself. Then we have a test-driven development intro class that just kind of gives you an idea of what test-driven development is. And we have a Git intro, so introduction to using Git. I'd like to make a more advanced Git class. I haven't quite put that together yet. I'd also like to do a continuous integration class. I don't have that up yet either. So that's what we got going on. You can check out our website at SAS Workshops, and it's got a list of workshops and things. The Git intro and probably the unit testing intro and the TDD intro, I'm going to try to put those in video form so you can just pay a small fee and get access to the videos. Right now it's all was in-person workshops. Now due to the coronavirus, it's all Zoom workshops. We have our mastermind group, which I showed you. We do personalized coaching, so if you have a specific need, you're like, we really want to improve X, Y, Z, or we really want to learn about a certain thing, you can hire me just to teach you about that. And I even do little things like just doing a code review or design review just to make sure you're on the right track, which I find is actually really valuable if you're the only LabVIEW person at your company. Not having people to bounce ideas off of sometimes, having somebody come in and just look over your shoulder and look at what you're doing. I might see things that you missed. So, and if at any time you want to schedule a call and just talk about what you're doing and see if there's some way that we can work together, you can use that link or that QR code to schedule a call. So that's the end of my presentation. If you guys want to ask questions, you can ask them in the chat, or you can just unmute yourself and ask questions. I'm curious if you have any feedback on the presentation, liked it, didn't like it, if it made sense. Yeah.
Hey,
Tim.
Hey, thanks for the presentation.
Yeah. No.
Yeah.
So
I basically do a lot of this, but not automated at all. So working toward getting it all automated. The
Okay.
continuous integration in particular. And I use Subversion, and as you said, it's kind of a pain to do any branching and merging. My team is
Yeah.
only was two. We've had to downsize due to coronavirus. So the
Yeah.
branching and merging hasn't been a major sticking point because I'm such a small team that I just work in my main branch. So.
Yeah.
But I've been meaning to get into Git because of what you mentioned specifically with the local changes and then pushing to the master branch.
Yeah. No, I find that the branching it changes the way you think about things because it helps you to like segregate things in your mind. And also like when you get into the continuous integration, there are certain points when you want to run tests and you want to make everything pass, and there's certain points where you don't care, right? Like if you're in the middle of adding a new feature, you don't really care if the test passes until you're done with the feature, right? And then at that point, you want to make sure that the test passed. So having that separate branch where you don't care, and then when you merge back into the main or master or trunk or whatever you want to call it, then run those tests. That makes a lot of sense.
Yeah.
So it just gives you more flexibility.
Yeah, I do a lot of, obviously tests as I go, but
Yeah.
what I need to do more is make tests so that I can test that my new change that I test individually doesn't break anything else around it.
Yeah, like the regression testing. Yeah.
Yeah.
Yeah. Well, the other thing that I find really useful about Git and that model is that I can try things out locally really easily, and I can even make several commits on a branch, and then I can throw it away if I don't like it, right? Whereas Subversion, the trouble of going to making another branch is a pain, and then anything that you change when you if you make a commit on that branch, now it's public and everybody can see it. So I find that really useful. But the thing that sold me on Git the most, if it really, because I used to use Subversion, I think everybody probably did at some point, but was I talked to somebody who said, he would go on site to different places and they didn't have internet access. And with Subversion, if you can't access the repository, you can't really do anything. Right?
Yeah. That's another thing I've run into.
Yeah. So for me, that like when I started doing consulting, I would go places and they didn't have internet connection. It was such a pain. That really totally made a sense for me because you can just check in locally, and then when you get back to where you have access, you can push it and you don't lose anything. And so
yeah, I've definitely run into that on site.
Yeah.
And
so
it's a lot of undoing and hoping you have them all in your buffer.
Yeah, exactly. So but that's pretty cool. If you're interested in switching to Git at some point, I have this Git intro thing that I'm working on. I don't have it all done yet. So, but if you send me an email, I'll give you a link and you can kind of check it out.
Yeah, I do it a little bit for personal things, but I don't do enough personal things to have gotten into all the branching and commands. Just the basic push and pulls. Yeah.
I have a series of articles I've wrote on my blog recently. I don't know if you've been following those, but it gives you a little bit more information.
Yeah,
so.
I recently started following you on Twitter. I don't think I've seen your blog yet.
Yeah. So sasworkshops.com/blog. You're on my mailing list now, so you'll get updates when I post new blog posts. But
all right, sounds good.
But there's several on there, and if you're moving from Subversion, so you probably use like Tortoise SVN.
Yep.
Okay, so I will make a recommendation. When you move to Git, skip Tortoise Git.
Yeah, I've picked that up at some of the CLA summits.
Yeah, I mean, it's not terrible. It works. The problem is it kind of keeps you in that old mindset.
Right.
And also, too, like some of the commands, like it uses the word in the way SVN uses it, but Git uses it completely differently, and it's just kind of confusing. So
yeah, I use, like I said, with some personal projects, I have GitHub, and then the other one with it's like a cat logo, an orange cat.
Yeah. Well, GitLab, I think maybe, but what I do, I honestly do have Tortoise Git installed on my computer just because I like seeing the little folder icons. So that I know, like, if I change something, it's immediately obvious. But I don't really. I go back and forth. I used to use SourceTree a lot, and there's some better ones than SourceTree, but SourceTree's free. So if you like the graphical style, source tree is pretty good. I've gotten back to using the command line a lot because it's just, for me, it's quicker and more powerful. But, you know, if you're not comfortable with that, source tree works really well. So,
yeah, I have that installed on one of my many laptops here.
yeah.
It's very novice still, though.
Hey, man, you got to start somewhere. So,
Yep.
but yeah, the problem I see is a lot of people stay at that novice level and never really learn how to use it. And
Yeah,
I mean, it's not terrible, but I feel like you're missing out on a lot of the benefits. And if you do enough software development to the point where you're using it every day, you know, being a little bit more efficient or a little bit better understanding really pays off because you use it all the time. So,
right.
yeah.
Yeah, you're a couple minutes during a presentation about Git.
Yeah.
Define me pretty much with you. So.
But you never fully understand Git. So don't ever try to like fully understand it. I have a pretty good understanding of it, but I still have to look shit up all the time. So, but that's another reason to use the command line though, because if you have to go look up questions on like Stack Overflow or something, all they're going to give you is a whole bunch of command line stuff. And you're like, oh, right. And if you want to try to figure out how to do that in source tree, you're like, oh God, what the heck do I do? Yeah. So. Cool. Any other questions? Anything else I can help you guys out with?
No, that's it for me.
All right.
So, thanks again for putting it together.
Yeah, no, thanks. I appreciate you guys coming. Usually we have more people, but like I didn't start advertising till last week. Usually I advertise like a month out. So
yeah, I think I saw it only a couple days ago. So.
Yeah, well, I think too, people are just kind of like burnt out from coronavirus because everybody's doing everything over Zoom, and it's like, how many Zoom conferences can you sit in a day?
Yeah, it's a lot easier to lose focus.
But yeah, I do these workshops every even month, so there'll be another one in 2 months. So if you have any ideas, send me an email and let me know, and I'm happy to see if I can put something together. I used to just go through all my old presentations from various conferences, and I ran out of topics. So yeah, so I'll probably start doing some reruns at some point. But
yeah, do you create a list of those on your blog or your website?
Yeah, so there is a list. If you look in the blog, there's a category called webinars, and it lists all the previous topics. So if you see one of those that you like and you missed it and you want to see it again, we can do that. And I have a YouTube channel, and I can give you the link to that if you give me a second. But I put up the ones from last year. I don't think I have this year's up yet, but I can give you a link. Yeah, I'll give you a couple links. Hold on a sec. While we're here, I gotta sign in. All right, why did that not fill the thing? There we go. I'm still sharing my screen. Oh, where's my channel? How do I get to my channel? Your channel. If you go there, there's a whole bunch of stuff. There's that. I'll send you a link to my blog too. And to the there's the blog. Here's a list of webinars. There's a whole bunch of stuff on my website that you might find useful.
Awesome.
Yeah. So, cool. All right. Well, if that's it, I think I'm going to take off a few minutes early. So, nice talking to you. Hopefully, maybe I'll see you around somewhere. I don't know if you go to any of the conferences or anything, but
yeah,
might be a few months before we go to any of those.
Yeah, I've done not as much as I'd like, but a few CLA summits and the GDevCon in Boulder. I was planning on attending. I'm in the Loveland area, so pretty local to you.
Yeah. So there's a group of us, and it might be too far away for you, but we typically get together. I'll send you an invite, actually. So we have a Slack group for there's the local alarm group. I don't know if you're familiar with them.
Yeah, I've been to a few of those meetings. It's been a while because I used to live in Broomfield, and the Louisville meeting was really nice.
Yeah.
From Loveland, it's hard to get down to Golden.
Yeah, I could see that. Yeah, so I'll send you an invite, but we get together. We were getting together every other week or something in Boulder for coffee, and then coronavirus happened and whatever. Now we just do it virtually, but I'll send you a link. Cool.
Yeah, that sounds great.
All right. Well, thank you.
All right.
Talk to you later.
Take it easy.
All right, thanks.
Have a good
Bye.
day.